Well, what we're going to look at now is found on page 174 in chapter section 3-5, where we're dealing with operations with matrices. And in example 5, in the body of that example, it's taken some data of a company that has 3 offices, and it's got 3 levels or 3 categories of employee: entry, assistant, and associate. And for a 5-day period, they have computed the wages and the sales for each of these 3 types of employees: entry, assistant, and associate. And we're asked here to use the data included to calculate the average yearly sales and wages for the company, assuming 260 working days. And so again, what we have here are the wages and salaries for the entire company for a 5-day period. Now, if we're going to use this data in this matrices, which is a 5-day period, and we're trying to determine what it's going to be for 260 days, well, we got to know that I need to take 260 and divide it by 5, which is going to equal 52. So basically, we're looking at 52 weeks of data. So I'm doing this so that we can show how on a calculator, because we've looked at multiplying by a scalar, and that's what we're going to do, is we're going to take this scalar right here, and we're going to multiply it by this data that we're getting ready to put in a matrices on our calculator. All right, so we had data on wages and sales for 3 levels of employees: entry, assistant, and associate. And we're asked to find, that was for a 5-day period, and so we're asked to find that for 260 days, or which is 52 weeks. So 52 is going to be our scalar. But let's go in here and let's get our matrix put together. So I'm going to hit second matrix, and well, let's just go down to C. I don't know, we'll just use A. Let's go over here and edit. I think that'll work fine. No. Well, let's change this to a 3x2. Could have set up a whole new matrices with different dimensions, but whatever. All right, so we got a 3x2 matrix. I'm going to be changing the data in here to fit what we saw before. So I got in row 1, column 1, I've got 14,250. And in row 1, column 2, I got 1,882,500. That's as in sales. And you see that expresses that as 1.88 e to the 6th, or 10 to the 6th power. So in other words, I could take that 1 and move that decimal place to the right 6 places, and that would actually equal 1,882,500. All right, let's see. Now in row 2, column 1, we got 30,000. And in row 2, column 2, we got 2,527,500. 527,500. And again, that's expressed in scientific notation. And then in row 3, column 1, I've got 31,500 for wages at the associate level for the week. And the sales from that group was 3,002,500. 3,002,500. Okay, let me look at my data here. 14,250, 30, 31,500, 18, 2,527,500, and 3,002,500. Okay, well that looks good. All right, well, so let's go back to our math screen. And remember now, our scalar for this is going to be 52. So I'm going to take 52 times, and I'm going to go in here to second and hit my matrix, which is right here where I got the inverse of X button, right by the sign button. I'm going to hit that, and I'm going to want to choose matrix A. That's where I entered my data. And let's hit enter, and shazam, there we go. So for the entry level, they had for the year, their salaries or wages are $741,000. And they're generating $97,890,000 in sales. At the assistant level, total wages are $1,560,000, and they generate sales of $131,430,000. And at the associate level, they have total wages of $1,638,000, and that group is generating sales of $156,130,000. There we go. Okay. Well, how about this? Anyway, just a little demonstration how we can use this, how we can multiply a matrix by a scalar.